Hi, brother and sisters. Hope all of you are doing fine. In this video, we'll discuss how to solve first order ordinary differential equation using separation of variables method. So, if the differential equation is of the form dy dx equal to g of x h of y, that means dy dx equals to product of function of x function of y, then we can use separation of variables. Similarly, when dy dx is equal to function of x divided by function of y, we also can apply separation of variable. But when dy dx is equal to g of x plus minus function of y, we cannot apply separation of variables. So in this slides, I will show you when we can apply separation of variable methods, when we cannot apply separation of variable methods. You can see in the first example, we can write y squared x e power 3x e power 4y is equal to say g of x h of x. That means product of function of x and function of y. Here g of x equals to this, y h of y is equal to this. That means in this case we can apply separation of variable methods. See in the second example, when dy dx equals to function of y g of x, we cannot apply separation of variable because we cannot separate them as one side function of x, one side function of y. In this slide, I'll show you how to apply separation of variable methods. Here the equation is dy dx is equal to e power 3x plus 2y. This one we can write as e power 3x e power 2y. So it looks like function of x is of y. Now we can write this equation 1 by e power 2y equal dy is equals to e power 3x dx. Now when we integrate both sides, we get this one e power minus 2y dy is equals to e power 3x dx. When we integrate this one, we get e power minus 2y divided by 2. Here we get 1 by 3 e power 3x, because in integration we have to divide by the coefficients of x equal to c1. So now we can say now when we can simplify this one, we will get minus e power minus 2y is equal to 2 by 3 e power 3x plus 2c1. Now when you take ln on both sides, we get ln of e power minus 2y is equal to ln of 2 by 3 e power 3x plus c. Here we write 2c1 equal to c as arbitrary constant. So this one we can write 2y is equal to ln of 2 by 3 e power 3x plus c. So we can say y equal to half ln 2 by 3 e power 3x plus c. So this is the answer for this question. So in next slide we will discuss another example. So now we will discuss sin x du dx plus cos x u equal to 0. We'll solve this problem using separation of variable methods. So you can see here u is the dependent variable, x is the independent variables. So when we rewrite this equation, sin x du dx is equals to minus u cos x. Now we can write this equation du dx is equals to minus u cos x by sin x. Now we can separate the function of x is one side, function of u is another side. That means we can write 1 by u du is equal to minus cos x by sin x dx. Now when we integrate both sides, we get ln of u is equal to minus ln of sin x plus ln of c1. Here we consider ln c1 as arbitrary constant, that means integrating constant. So do you know how to get this integration? Because we know that if integration of f prime x, f of x dx is equal to ln of f of x. That means if the numerator is the derivative of denominator, then the integration of f prime x by f of x dx is equal to ln of denominator. So now we can say ln of u is equals to ln of c1 divided by c1 divided by sin u, because ln of a plus ln of b is ln a b, ln of a minus ln of b is equals to ln a by b. So now we can say u equals to c1 by sin of x. So this is the answer. So we can say this is explicit form of solutions. Here we are going to discuss another example. Say this equation we can write dy dx minus 6 sin 3x divided by y is equal to 0. Now we can write dy dx is equal to 6 sine 3x divided by y. So now we can separate x in one side, function of y in another side. So now we can write this one dy is equal to 6 sine 3x dx. Now we can integrate both sides. We'll get half y squared is equal to 6 1 by 3 minus cos 3x. So this one we can write now half y squared is equals to minus 2 cos 3x plus c. C is integrating constant here. Now we can say y squared is equal to minus 4 cos 3x plus 2c. Now we can say y equals to square root of c minus c1 minus 4 cos 3x. Here I wrote c1 means 2c. C is arbitrary, so this is the answer. So in the next example we check we can we apply to solve this differential equation by separation of variable methods. Now you can see here when we rewrite this equation in this form dx dt, because here x is the dependent variable, t is independent variable, x plus t e power t. That means this equation look like dx dt is equals to function of dependent variable plus function of independent variable. So in this case we cannot apply separation of variable methods because we cannot write this equation in this way. Function of x dx is equal to function of t dt. We cannot write this equation in this form, so we cannot apply separation of variable. So in this case we have to use integrating factor methods. In next video I'll show you how to use integrating factor method to solve first order ordinary differential equations when we cannot use separation of variable method.